Okay, so here we have question one for the project. This is on 3D equilibrium or section 2.5. The question is a stationary ceiling fan, which means it's not moving or rotating, it's just still, that weighs 50 kilograms is supported by 3 cables. And then in doing so, we want to learn the tension in AC. So I've already taken the liberty of coloring our cable AC in a different color right here. If you could tell, it's this area. So what I'm going to start off by doing is grabbing the points of, well, all of the major points on the graph. So we'll start with A, then we'll go to B, then we'll do C, and then D. So the point of A is going to be at 0, -10, comma 0, because it's only changed in the y-axis. Then moving on to point B, as you can tell, hasn't moved anywhere on the x-axis, so that means it's 0. It hasn't moved on the y-axis either. However, it is 5 meters away from the origin on the z-axis, which means it's going to be 5 there. And now we move on to point C. Point C is very similar to D. However, if you notice, it's on the opposite side of the axis, which means that it's actually going to be a negative number. So at that point, it's 0, 0, -2, because if it's on this side of the axis here, which means that it has to be that it's going to be a negative value. Now I move on to D. D is a little different because it's not on any of the axes. So first we're going to look at the x, and if we look at x, we notice right here that is how far it is from the x-axis. So we got 3. Then it hasn't moved off the y-axis. So it hasn't moved from the y-plane. Sorry about that. I meant y-plane. And then it's 1. If you notice, it's 1 meter off of the z-axis, which means that it's the x-axis, which means that it sits at 1 there. Now what I'm going to do is I'm going to figure out the magnitude of each cable as well as the overall points of each cable that it goes between. So first things first, I'm going to do AB. So when I do AB, what this equals is B sub x minus A sub x, comma B sub y minus A sub y, and C sub z minus, not C sub z, sorry about that, B sub z minus A sub z. So I'm not gonna, that's how it always is. You do the start point minus the end point, because it's being supported by the cables, which means the force goes up on all of these. So therefore it starts from A and then ends at the opposite point. So when I do this out, I end up getting 0, 10, 5, because when I do this, it's 0 minus 0. Then I go here, and it's 0 minus a -10, which then becomes +10. And then here, it's 5 minus 0, which gets us our point. Now I'm going to calculate magnitude of AB. And when you calculate magnitude, what you're actually doing is you're grabbing A, B, and you square. So you square each one of your individual points. So you do 0 squared plus 10 squared plus 5 squared. So when I do this out, you end up getting rad 125, which when you plug into your calculator, you'll get 11.180. So now what I'm going to do for AB is I'm going to calculate lambda AB. So lambda AB equals the AB point, the AB ray or line divided by AB. So this equals the 0 divided by 11.18, comma 10 divided by 11.18, comma 5 divided by 11.18. When you do that out, you end up getting 0, comma 0.894, comma 0.447. So that is our lambda AB. Now we're going to do the same thing for BC and BD. Sorry, not BC, AC and AD. So I'm going to do those out quickly. So here we're going to start off with AC equals, so it's going to be all the C points minus the A points. When I do that, I'm going to end up getting 0 minus 0, so that's 0, comma, and then I'm going to get 0 minus negative 10, which gives me 10. Then I do negative 2 minus 0, which gets me negative 2. So now that I have that, I move on and look at calculating out my magnitude. So my magnitude for AC is going to be the square root of 0 squared plus 10 squared, and then it'll be plus negative 2 squared. So when I do this out, you get as a total 10.198. Now what I'm going to start doing is I'm going to calculate lambda AC. So lambda AC equals my AC values divided by my magnitude of AC. This equals 0, comma 10, comma negative 2, all divided by 10.198. You can write it this way or the way I did for AB. It makes no difference. The way I did for AB was actually just multiplied out. But when I do this, I end up getting 0, comma 0.981, comma negative, because we have the negative 2 there, 0.196. So given that that's my lambda value for here, I'm now going to calculate out my last lambda that I need. So I'm going to do AD. So AD is going to start off by grabbing the point again. And when I do this, I'm going to take my, I'm going to do each of these D values. So I'm going to do 3 minus 0, which gets me 3, comma, I'm going to do 0 minus negative 10 now, which gets me 10 again. And now I'm going to do 1 minus 0, which gets me 1. Now I have to do my magnitude. So my magnitude of AD is a little more complicated than the rest simply because we have 3 numbers, but it's still done the same way. So this equals the square root of 3 squared plus 10 squared plus 1 squared. So when I do this out and plug this into my calculator, what I'll end up getting is I'll get 10.488 as my answer. Now what I'm going to do is I'm going to calculate lambda again. When I calculate lambda, Sorry, this should actually be capitalized up here. Oh, nope, didn't mean to write AD, my bad. When I do this, it's going to be AD divided by the magnitude of AD. This all equals my 3, 10, 1 divided by 10.488. When I do this out, I end up getting my values of 0.286, 0.953, 0.095. Now that I have all of my lambda values that I'm going to need for this, I'm going to go back up here and keep in mind, and I'm now going to look at the weight. So whenever I'm looking at the weight of a ceiling fan, it doesn't have any direction on it, which means the weight is, all of it is just going to be downwards, which means it's only going to be in the y-axis. So if it's only in the y-axis, what I'm going to end up doing is, what I have to do to actually figure out the amount of force it presses down, because all I know is this problem gives me the weight. I have to calculate out my weight, which equals my 50 kilograms that I have times the force of gravity, which we're going to use 9.8 for, which gives me about 490 newtons when I plug that into a calculator. So now we're going to start using our 3 main equations for to try to solve out to try to get AC. So first things first, I have my sigma f sub x equals 0. I also have sigma f of y equals 0. And lastly, sigma f of z equals 0. So now using this, I'm gonna start off with f of x, because it doesn't really matter which way you start off with. However, I want to start off with f of x because when I look at each of these, when I look at my lambda values, I have 0.286, 0, and 0. So I have 2 zeros already, which makes me want to just start with it, because that means I can get rid of the AB and the tension values for those two, and I don't have to worry about it. It's just one less. It's two less unknowns for the problem. So starting out, we're going to grab sigma. That was a really bad sigma, but sigma. Sorry, I have to fix. It's somewhat sigma f sub x equals 0. So when I do this, that means whatever values I have in my x direction will equal 0. So I'm going to start that off now by saying I go through, and keep in mind my tension has to be multiplied by my lambda values. That way I actually have the amount of tension in that one direction versus the tension in all directions. However, we are still trying to find the tension of all the directions in cable AC. But to start off with, we're going to just do that. So we're going to do our TAB, which gets multiplied by 0, plus our TAC, which is also multiplied by 0, plus our TAD, which gets multiplied by 0.286. And all of this equals 0. So what I'm going to do is I'm going to first get rid of my 0 values. And when I do that, I'm left with TAD times 0.286 equals 0. So now if I was to divide by 0.286, I'm going to get T equals 0. So this tells me that cable D is not supporting any weight. It's just kind of sitting there just to be there and connect on as a third point of connection. So that means come in the future for the f of the sigma f sub z equals 0, I can actually ignore my TAD value. So going in, we'll start off with z because I'm going to try to avoid the w. I'm going to try to avoid adding this extra value in for as long as possible because it just makes it a little more complicated. So that being said, we are going to do sigma f sub z equals 0. So when we're doing this out, we're going to grab all of our z values. So we're going to first start off with our TAB. And TAB is going to be multiplied by our 0.447. And now I'm going to subtract simply because, well, realistically, I can also just say I'm adding it, but I was just trying to get rid of the negative earlier. But I can do TAC times my AC value of negative 0.196. That's why originally I was saying subtract before I just decided to change my mind to add it, because this negative will make it will subtract it for me. Versus if I made the sign negative, I would have just simply wrote 0.196. So then we will now keep in mind we just solved for TAD, so it's going to be, so realistically I'm going to do my TAD value times my lambda value for z. However, since it's 0, I'm just simply going to write in 0. So plus 0, and that equals 0. So doing so, I'm going to just multiply these out real quick. And I'll get 0.447 TAB minus 0.196 TAC equals 0, because I can just cross out this other 0 value because it's 0. So now what I'm going to do is I'm going to add to the other side, and because I'm trying to solve for TAC, I'm going to try to make my f of y all in terms of TAC. So that way it's my only unknown, and that way I'll have my answer immediately after. So when I do this, I'm going to solve for my TAB value, which means I'm going to do 447 TAB, because I can add the negative over, which makes it positive, to 0.196 TAC. So now I'm going to divide by the 0.447. And when I do that, I get TAB equals 0.439 TAC. So now this brings me into my f of y. So I'm going to bring my f of y all the way down here. F sub y equals 0. Now keep in mind, we already established that this weight up here, I'll grab a different color so it kind of sticks out. This weight right here has to go downwards. So that means it's going to be a negative force, because that's what all the cables are holding up. So given this, I'm going to write out my values. So I'm just going to start off by writing TAB. However, we will end up substituting that. So we're going to do TAB times its 0.894 value plus TAC times its value of 0.98 and then we do plus TAD, but TAD is 0, so I'm just going to do plus 0. And now I have to subtract the overall force I get from the ceiling fan, which is my W value there, which equals negative 490. So minus 490. This equals 0. Now, keep in mind, I don't have to multiply that 490 by any value because it is directly down. It doesn't have any terms to it and doesn't give any force in any direction besides in the y direction and downwards in the y direction at that, which makes it negative. So when I do this out, I'm now first going to actually substitute my TAB value for substitute my TAB value out because I have TAB equals that conveniently. I can also get rid of my 0 because it's 0. So in doing so, I can, and I'll also move over my 490 here. I'll move it over to the other side. So that way I'll have just TAC on my left side of the equation and 490 on my other. So when I do this out, I'm going to substitute that. So I'm going to get 0.439 TAC times the 0.894 that was supposed to be multiplied against TAB. And then I'm going to add that to 0.981 TAC. And this equals 490. So I'm going to multiply out my 0.439 and my 0.894, and then I'm going to add it to my 0.981. So when I multiply out my 0.439 and I multiply that by my 0.894, I'm going to end up getting 0.392. I'm going to get 0.392. And that would be TAC plus my 0.981 TAC that I already have. This equals 490. Now keep in mind, all of this is in newtons, and that's going to come up when we get our answer because our answer will be in newtons. So now when I add 0.392 to my 0.981, sorry about that, mistyped something. I'm going to get 1.373 TAC equals 490. Now I'm going to divide by my 1.373, which then gives me TAC equals 356.93 newtons. And that is my tension in cable AC, because that's what TAC stands for, which means this is my final answer for question 1. Thank you.